For this video, we're going to talk about how you set up a calibration plot for your iron thiocyanate experiment. This is going to allow you to determine the molar absorptivity specific to iron thiocyanate at a wavelength of 540 nanometers. Remember, we're still using Beer's law, so we know that absorbance is proportional to concentration of something in our reaction system. In this case, we're interested in the iron thiocyanate at equilibrium. So the absorbance that you're going to be measuring is actually your product of your reaction system. This time, in this experiment, we are not giving you that proportionality constant, that epsilon times B value, so that's what we're going to be determining in our experiment. And if we look at how this equation is sort of set up, we can see that if we plot absorbance versus our iron thiocyanate concentration at equilibrium for our reaction systems, then we're going to be able to determine a value for the slope. Now, the intercept for this particular plot should be equal to 0. If you think about it, if there's no iron thiocyanate ions present, there shouldn't be anything in that system to be picking up light. So there shouldn't be any light being absorbed by our sample if we don't have any iron thiocyanate present. So that plot of absorbance as y-axis values versus iron thiocyanate concentration as x-axis values, we're going to use that to determine our epsilon times B value. We're going to be able to add a linear trend to that plot to get our linear equation, and also remember to include the R squared value, because that's going to give you vital information on how good your results are, how close your data points are to that linear trend. Here I have an example of what your plot should look like. This is just data that I collected from a previous semester, and you can see that the students has plotted absorbance data as their y-axis data, no unit associated with that, and the x-axis data there is the iron thiocyanate concentration at equilibrium. There is a unit associated with that, and that unit is molarity, so that's clearly displayed on their plot. They've also put in a trend line, and we have the equation relating to that trend line that we've got there. And we've also got a nice R squared value there, and you can see just how good those points are fitting to that trend line. That R squared value is very, very good. Remember, the closer that value is to 1, then the closer your points are to the linear trends that you have printed on your chart. So this is very, very good data. Now, if we just take a look at the intercept, however, with this plot that's been generated, we can see that it is not equal to 0. It's a very, very small value, but it is greater than 0. And we'll talk about that a little bit on the next slide. But overall, this is a pretty good plot. Let's take a look at the equation from the plot. So that value of 1.84 times 10 to the 3 for the slope of this plot is pretty average. That's about the value that you're looking for. That sort of ballpark figure there for your epsilon times B value. So that's pretty good for your slope. All right, let's take a closer look at the intercept. So again, it's not exactly what we're looking for. It's not exactly 0. So let's think about reasons why it might not necessarily be 0. And it's not a bad thing. It's perfectly fine. Okay, it might be due to errors in dilution calculations. For example, you're assuming that you've collected the appropriate volume, but it might not necessarily be the exact volume you're using in the experiment. And you do perform a series of dilutions to actually come up with the reaction system solutions that you deal with in this particular experiment. Another problem might be the fact that each of the spectrophotometers that we have in the lab are all calibrated slightly differently. It is very important that you collect all of your data on exactly the same instrument, because then what you can do is use that intercept value as effectively a correction factor for your particular machine, for your particular spectrophotometer. So there's a few possibilities of reasons why that might be the case, why you're not necessarily getting a value of 0 for your intercept there. But it's not, as I said, it's not necessarily a bad thing. It's a real world thing. It's what we deal with all the time in lab, so no worries.